create a directed graph from this. Okay. Okay, so now I just need to do DFS. So if the answer has not been calculated yet, for K. Going to submit if this passes. Okay. Okay, this is updating. This will take a while to update, so I'll just go over my solutions right now. So the weakest row. So basically, first we need to sort by the number of soldiers in each row, and if the number of soldiers is the same, then we sort by the index. So what we can do is, for each of the rows, we'll create a pair of two integers, and the first element of the pair will be the count of the number of soldiers in that row, and then the second element of the pair will be the index. So when we sort these pairs, it'll sort first by the count of the soldiers, and then it'll sort by the index, which is what we want in the statement. So after we sort it, we basically go through the first k rows, and then we add the index to the answer. And yeah. For the second problem, first, basically create a frequency array of the original array. So the map over here, basically, the key is the value in the original array, and the value of the map is the number of times it appears. So I go through each element in the array, and then I add 1 to the count of that element. And after that, I iterate through all pairs of the frequency array, and then I add the count of each element into a vector. And then you want to choose the elements which appear the most. So that's why I sorted this vector. Then I started adding the counts from the elements with the elements with a greater, which appear more frequently. So that's why I go from the back. And while the current sum is, while 2 times the current sum is less than the length of the original array, we basically keep taking new elements. And yeah, that's it. And for the maximum product of for this problem, in my first DFS, I calculate the total sum of all nodes in the tree, and then which will help me calculate the answer in the second DFS. So in the second DFS, this variable here, S2, it represents the total sum of all nodes in the tree. Then basically, we can calculate the product of, you basically try each edge and then see which edge gives the biggest product. And for example, if we remove this edge, then the first subtree will have a sum of S, and the second subtree will have a sum of the total value of all the nodes in the tree, which is S2 minus S. So basically, if we have a subtree with size S, then we just need to check if S times S2 minus S is greater than the current answer. So we do a similar DFS where we calculate the sum of the sizes for each subtree, and you also calculate the maximum answer for each subtree. And then for the answer, we basically we check it with the answers within the left and right subtrees, and then after that we check it also with the answer of removing the current subtree. And then after this DFS2 happen after it finishes processing for the root, then the second argument, the second value of this array will be the total, the answer that we want, and we just modulo it with this value. And for the last problem, we can create a node. First, you need to notice that if we create an edge from I to j with this condition, then for all pairs of nodes I and j, then we will get a directed acyclic graph. Because if we can go from I to j, and that means that the value of I is greater than the value of j. So it's impossible to get from j to I because the value of j will always be smaller. So basically you can construct a directed acyclic graph from the given array. And then after we do that, we just run a dp on the directed acyclic graph to find the longest path. So I'll describe how to find the graph in more detail. So we fix a node I and we want to know which nodes we can reach from it. So let's process, we can process the nodes which are on the left of I first. So we maintain a variable max, which is the maximum of all the values from I all the way to j. And then first we need to check that j is within, this range, is within these steps of I. And if it's not, then there's no edge. Otherwise, there will be an edge created if the value of I is greater than the maximum of all the values of j so far. I can do a similar thing for all j that are to the right of I. And so after we do this process, you'll find a directed acyclic graph, and it will be stored in the adjacent array here. And so we first clear the dp array. Then for each node, we calculate the longest path starting at that node. So we call this function cdp, and we basically return the maximum of all such paths. And the way this function works is, if dp of u has already been calculated, then dp will be greater than 0. So this entire thing won't execute and it'll just return this. However, if dp of u has not been calculated, then basically it will go through and find all of the edges from u to some other node I, and then it'll take the maximum of dpi over all such edges. And lastly, we need to add 1 to count the node u. So for example, if dp of 10, dp of 8 will be 3 because there's a path starting from index 8 with length 3. And then if the current u is 10, then dp of u will be maxed with dp of 8, which is 3. So after this for loop, the dp of 10 will be 3. Then we add 1 to dp of 10 because you also need to count the index that we are currently on. So that's why we add 1. Then after we process it, we just return it. And yeah, that's basically it. Oh, okay. It's actually my first win. So this is pretty nice.